Hello, and welcome to our presentation. My name is Todd LeBeau, and together with Aklam Desta and Jose Ramirez Casada, we are the development team tasked with implementing the Intelligent Recreation System for David Levy and Mobility Next. Before we get started, we have a question for you. Who here wants to go on a hike? How about now? Or now? We're guessing the answer is no, if those are the crowds you'll encounter on the roads and trails. Current trends in outdoor recreation have created unsustainable demands on our public lands and roads, and the COVID-19 pandemic has only exacerbated the problem as the population looks for new ways to recreate in outdoor situations. As a result, we are rapidly degrading natural resources and experiencing untenable levels of trail use, traffic, and infrastructure strain. Historically, the tools that land managers have used to track outdoor use have included such things as counting trail users by hand, parking lot vacancy rates, how often the toilet paper needs replacing at a trailhead, or how frequently pit toilets need to be pumped. But all these tools measure land use by looking backwards in time. This can result in strikingly divergent predictions of future use across various land management agencies. By conceptualizing the capturing of dynamically produced data, such as location-based services, social media, and website metrics, the Intelligent Recreation System provides land and transportation managers with new tools for measuring and managing recreation demand. Using machine learning and/or artificial intelligence techniques to analyze these large and diverse data sets, land managers and policymakers can then quantify recreation demand before it hits the roads and trails. With this information, strategic interventions can then be applied to balance recreation use in real time by nudging land users to recreational areas which are less congested. The IRiS platform is built with three technologies. The user interface was implemented with the React.js framework. The middleware was implemented with Django, which is a high-level Python web framework, and a relational database hosted by Amazon Web Services. The platform itself is divided into two sections. One for the general public to search for or discover new trails, and the other section, which is designed to give land managers new tools to visualize both historical and, more importantly, future trail use. Another underlying principle of the Intelligent Recreation System is to nudge users to less crowded trails, thereby not overwhelming public land resources. To do this, we devised a system of both a current score and a threshold, which we apply to each individual trail. The current score is an aggregation of data sets we are conceptually capturing. These novel data sets, which include such metrics as social media, mobile phone GPS tracking, and web content views, combine to give us the current score of a trail, which is a real-time depiction of recreational traffic a particular trail is experiencing. The higher the current score, the higher the traffic is thought to be. On the other side of the equation is the threshold statistic, which is what land managers deem to be the carrying capacity or number of recreationists the land can sustain at each individual trail. While the current score is calculated by actual demand found on the trails, the threshold is manually set by land managers to nudge land users away from overcrowded trails. This threshold, combined with the current score, also determines which trails are returned when users search for trail information in the Search Trails page of the user interface.
A few key aspects the IRiS team had in mind when designing the platform were simplicity, user experience, and productivity. Let's get into the thought process of implementing the dashboard. After gathering feedback from land managers about their preferences in working with software, we concluded they needed a platform that would keep them informed of crucial changes. The team acted by rendering a state table on the dashboard landing page. This table keeps land managers updated with the latest changes on trail scores. To improve this feature, the state of each trail is highlighted with a respective color to each state, from red meaning crucial to green meaning the state is in good condition. We've also added a section where the land managers can request visitor predictions of a particular trail. This feature allows them to not only make better decisions, but also enables a much better management system. Overall, the user interface and user experience allow land managers to focus on the important tasks. With great power comes great responsibility. Taking advantage of the power Amazon Web Services offers, land managers are granted access to real-time changes to our online hosted database. With a 99.95% uptime, online hosting increases our data availability and durability. By granting access to such services and providing them with prospective visitor data, we are allowing land managers to take control of the situation and acting upon it before any harm can be done to our public lands. We've made sure to keep user experience consistent throughout the platform by implementing color-coded bar graphs and allowing flexibility within our forms. We are certain our users will enjoy these design characteristics that take into consideration the thoughts of land managers themselves.
Some of the challenges. There are four challenges specifically we face throughout our work project. So the first one is remote collaboration. So when we work remotely, we faced some issues. Some of our the internet outage or the computer might be malfunction. Sometimes the computer will stop in the middle of the work or the internet might be down, so hard to continue our work. Even with the decent Wi-Fi at home, our virtual meeting can be frustrating due to internet glitches. And the second one was distraction. In the middle of the work, we might use social media, overuse social media, or take a nap in the middle of the work, and some noises from outside. That may be a biggest distraction. And the third one is different working hours. So some of us have a job, so some of us were active in nighttime, some of us were active in the daytime, and so it's hard to keep the connection active. And the second one was software deployment. When software deployments, we have to do a big research to find paid and unpaid services to deploy our softwares. Plus, we have to learn the platform to deploy software. So when we deployed the software, we found some free version to deploy our front end, but in order to deploy our database and backend, we have to pay a little amount of money to deploy. That's the toughest decision that we made. We have to pay in order to deploy the software. And the third one is the learning curve when choosing programming stacks. So some of us have experience in some frameworks and some of us don't. So we have to spend extra hours in order to learn and tackle all the problems through our projects. And the last one is the last minute. So last minute means we use agile methodology through our project. So every time there will be new updates for our project to add and remove some tasks from our project or from a website. So whenever we receive new implementation for our project, we're always happy and implement all the new ideas right away once we receive the new implementations.
And that ends our presentation. On behalf of Aklam Desta, Jose Ramirez Casada, David Levy of Mobility Next, and myself, Todd LeBeau, We hope you'll find your next trail adventure using the Intelligent Recreation System. Thanks for watching.